Okay, so in this review, what we're going to do is go over the 6-4-6-5 practice. And I'm going to add one other thing up here. 6.4 is SOHCAHTOA. So SOHCAHTOA is written here, but I'm also going to write it like this so that you know that they're ratios, okay? So it's there as SOHCAHTOA, which is fine, but I like writing it like this as well. And know that you can only do this for right triangles, okay? You can't do it for the obliques. Okay, here's your law of sines. Remember, for this test, there's going to be no ambiguous. So you will have no situations just for this quiz where you could have two solutions, okay? So it's no ambiguous. You're going to have one solution only just for this test. But you know that using law of sines, you're going to always look for the second angle, okay? As soon as you solve for the first angle, see if its supplementary partner could also work inside a triangle, given what you know. But we're not going to do that here, but we will do it in the future, and from now on, with the exception of this review and this quiz, you always have to think about the ambiguous case when using law of sines. Okay? Okay, the area of a triangle when using, well, for any kind of triangle, is always this. If you have a right triangle, you can use 1/2. Area is, so let me redo that a little bit. If you have a right triangle, you can say that my area equals 1/2 base times height. It'll only work in a right triangle when you have those two features automatically. To work in an oblique triangle, you have to get the height. That's why instead we use this area equation that has sine in it. Okay, so let's keep going. We'll talk about that stuff later. So it says find two values of theta between 0 and 180 that satisfy the following. Okay, so I have another little aside for you. Remember in class we talked about all students take calculus. So that means that all values, all sine, cosine, and tan values are positive in this first quadrant. But only sine is positive in the second quadrant. Since we're dealing with triangles in this section, we're only working on the first and the second quadrants. Okay, so this says what angle, the sine of what angle is 0.629. So what you're going to do is you want to find an angle. Whenever you want to find an angle, you're going to use inverse trig every single time. And I'm going to put 0.629 right here. And I put that in my calculator, and I want it to the nearest degree. So that means your mode right now is in degrees. Make sure that your calculator is in degrees. And you can put your float on 0. Okay, that will give you your angle to the nearest degree. When you do this, you're going to get 39 degrees. That is a quadrant 1 angle. We know that this sine value is the same for the angle in quadrant 2, that is its supplementary partner. To get that, we're going to take 180 minus the quadrant 1 angle, and that's going to equal 141, and those are your two angles that you need. Quadrant 1 and quadrant 2. Okay, let's get the next one. Do the same thing. Theta equals sine to the -1 of 0.913. So therefore, theta, when I put that in my calculator, I get a value of 66 degrees. 66 degrees is a quadrant 1 angle. I also have a quadrant 2 angle with the exact same sine value. To get that, I'm going to say 180 minus 66 degrees, and I'm going to get an angle of 104 degrees. So these are the two angles they're looking for. Okay, the next one says, if the cosine is this, okay, if the cosine is this, let's just figure out what that angle is. The angle is going to be cosine negative 1 of 0.242. That angle ends up being, oh, I'm not going to change one thing. Let me change one thing. You should have said, no, this is not 104. This is 114. So that should be 114. Okay, sorry. So keep going forward here. For the cosine, when I put that in my calculator, I get an angle of 76 degrees. Now, that's great to know, but they don't want that angle. What do they want? They want to know what angle satisfies this negative. Well, where is cosine negative for a triangle? That's going to be in quadrant 2. That's all we're going to look at right now, quadrant 1 and quadrant 2. So to get the quadrant 2 angle, you're going to take 180 minus 76, and that's where the 104 comes in. Okay, and that's the quadrant 2 angle that you want. Okay, so then they say, they're trying to trick you up here. If tangent theta is this, okay, if it's negative, that's in quadrant 2, by the way. What angle satisfies the positive? Well, we're never, ever, ever, ever going to put a negative in as a tan to the negative 1, or a cosine to the negative 1, or as a sine to the negative 1. The answer will mislead you. Always put in these values as positive, and be aware that you will always get back an angle in the first quadrant. This angle that they want is 57. Tan has a positive tan, the angle has a positive tan value in that first quadrant. This is the angle they want. So they wanted this angle here in the second quadrant. They wanted this angle here, and that angle is in the first quadrant. What if they said, what is this angle? To get this angle, you would have said 180 minus the 57, and you would have gotten 123 if they asked for that. But they wanted the first quadrant angle. So once again, never, ever, ever try to get an angle beyond the first quadrant using inverse trig. Always use your knowledge of how the quadrants work to get the angles in the other quadrant. And we'll do more with that. Right now, we're just looking for angles in quadrant 1 and in quadrant 2. Okay, let's look at this next problem. It says solve the following right triangle. Okay, so how are we going to do that? Well, I'm going to write SOHCAHTOA right here. So it's directly in front of my line of vision. I'm going to put myself in angle A's position. From angle A's position, this is the opposite, and this is the adjacent. From anybody's position, this is the hypotenuse. Okay, you want to definitely get that down. So I cannot use anything that has a hypotenuse in it. I can't use sine to solve for the angle because I don't have the hypotenuse, and I can't use cosine. My only option is using tan. So I'm going to say that the tan of angle A is opposite, which is 7, over adjacent, which is 12. Angle A is what I want. So don't put that in your calculator. Put this in your calculator all at once. Okay, you will get angle A to be 30.3. Okay, we should talk about the modes again. You want 1 decimal place. We're in degrees. So your mode is in degrees, and put your float off of 0 and onto 1. Okay, be the master of that calculator. Okay, so now I know that this angle right here, oops, so sorry, get that back up. This angle right here is 30.3. you can get angle B by saying 90. Now, how come I said 90? I said 90 because angle A and angle B are supplementary. So you can subtract the angle you got from 90 to get angle B, which is going to be 59.7 degrees. Okay, so this angle is 59.7 degrees. Okay, so now all you have to do is get the hypotenuse. So I use sine. I said the sine of the angle we found, which is 30.3, equals opposite, which was given as 7, over the hypotenuse, which is unknown. So then I did my cross products and said hypotenuse of sine of 30.3 equals 7. I wanted to isolate the hypotenuse, so I'm dividing by the sine of 30.3. And when I put that in my calculator, I got that I'm going to call this side C, which is the hypotenuse. And that is going to be, rounded to the nearest tenth, 13.9. Okay, what I could have done, and I had some of my kids do in the class, you could also solve for the hypotenuse using Pythagorean theorem. So how would you do that? Well, you would say the hypotenuse squared equals the leg squared plus the other leg squared. That is 49 plus 144. I add those together and I get 193. That's C squared. So C equals radical 193, but you can't leave it like that because I said I wanted my answer to the nearest tenth. So when I put this in my calculator, I get 13.9, and these two values match. So you can use Pythagorean theorem, or you can use this, and either way, you'll get the other side, which was the hypotenuse, to be 13.9. Now let's take a second and talk about reasonable answers. So big angles beget big sides. So this should be your biggest side. The side opposite angle A, which is 7, should be your smallest because angle A is the smallest angle, and that's what I'm seeing. The angle opposite B, or the side opposite B, should be the medium because that's the next biggest angle, and that's what I'm seeing. So these answers are reasonable, and doing that reasonable test is a good idea. Okay, let's continue. Okay, now the biggest problem that my kids tend to have with this is drawing the problem. So let's make sure we're getting that correct. So it says the leg of one side in a right triangle. Okay, so I'm going to do my right triangle. So here comes my right triangle. I'm going to make it right by putting in my little square. And it says the leg of one side. So I think I made my leg down here. You can make it the vertical leg. You just cannot make it the hypotenuse because they told you the hypotenuse, which is across from the box, is 10 inches. Make an accurate sketch. Okay, I think I did. I would reread this, make sure it looks like this, and then find all angles and all missing sides. Okay, so I went ahead and labeled this ABC. And I said I'm going to use angle A. From angle A's perspective, 6.2 is adjacent, this is hypotenuse, and this is opposite. So if I want to find angle A, I can't have more than one unknown, right? So I have to use cosine, and I would write SOHCAHTOA right here. So again, it's right in your line of vision. And I'm going to say cosine of angle A equals adjacent, which is 6.2 from that angle's perspective, over 10. Do not put that in your calculator. You are looking for an angle. So you're going to do inverse trig, and you're going to put this in your calculator. Now this says round to 1 decimal point. If you're doing this in order, you should be okay, but your mode is degrees and your float should be on ones. Okay, so I get an angle of 51.7 degrees. So this angle down here is 51.7 degrees. Okay, so let me make this a little smaller. And let me fix this. Okay, so let's get angle B. So angle B is just going to be 90 minus 51.7, because remember there are complementary angles inside the right triangle, and I'm going to get an angle of 38.3 degrees. So this angle up top is 38.3 degrees. Okay, so remember, you can use Pythagorean theorem to find the missing side as long as your setup is this. 10 squared, because that's the hypotenuse, equals 6.2 squared plus little side a squared. Okay, so you could do that. So let's do that. So this is going to be 100 minus 6.2 squared is 38.4. Okay, so 100 minus 38.4 is a squared, second square root of second answer, and I'm getting 7.8 for A. So this is A squared, so I get A is 7.8. I did not do it that way, but I got the same answer. So what I did was say that the sine of 51.7 equals A over 10, one-step problem. I multiplied 10 by the sine of 51.7, and I still got that my A side equaled 7.8. Okay, so either way you can do it. When you get to this point in math, there's lots of ways to do things. Okay, and that's true for this next problem as well. It says, once you have solved the triangle, compute the area. Well, this is a right triangle. So I can say 1/2 base times height is my area. So this is 1/2. My base is 6.2, and my height is 7.8. If I just do that, and I do 0.5 for the 1/2 times 6.2 times 7.8, whoops, sorry, again, 0.5 times 6.2 times 7.8, I'm going to get an area that is 24.2. Okay, these are inches, so that's going to be inches squared. Okay, so that's one thing. Now, you just learned a new formula for area, and that involves sine. That area I can use for any triangle in the world. It's 1/2 one side times another side times the included angle. So it doesn't line up with our letters necessarily, although it could, I guess. I guess it could. I just want any kind of sandwich. So I'm going to grab these. Okay, when I grab those, a side is 10, a companion side across from the, in between, you got sandwich, sandwich, jelly in between. The jelly is the angle. So it's 10, my other side is 6.2, and the angle that's included is 51.7. Now you have to make sure you write that sine word, because that's an integral part of the equation. Okay, so I'm going to say 0.5 times 10 times 6.2 times the sine of 51.7. Okay, I get 24.3 inches there, but that's close enough because remember we rounded. So when you round, you might have little rounding errors. So I would take either answer depending upon your procedure. Okay? Either answer is fine, but I wanted to show you both ways. Okay, next one. Here is a ladder. Okay, I'm going to try, let me not do that. Let me back out. I want to get nice lines. So that's vertical. Okay. So key thing is to understand where the ladder is placed. Okay, your ladder is leaning against the building. If it helps you to draw it more realistically, do that. If you've never climbed a ladder, which apparently many kids have never climbed a ladder because they put the ladder vertical and you'd be falling off the ladder, do this for yourself. Now it's placed against a house, right? So draw in your house so that you know exactly what you're looking at. The more realistic you can make it, the better handle you're going to have on these problems. Okay, so here's your house. Okay, so it says the base of the ladder is 13 feet away from the bottom of the house. Okay, this is the base of the ladder. This is the bottom of the house. So I need this value of 13. Make a sketch of this situation. Okay, I've done that. I would read this again, make sure that you have drawn it so that it matches the wording. And they say use this to find the angle of elevation in degrees that the ladder makes with the ground. Well, the angle of elevation is, here's the ladder and the ground. You're looking up to the top of the building. That's the elevation angle. I'm going to put it there as theta. Okay, so you're back in the world of SOHCAHTOA. This is a right triangle. I'm just going to write SOHCAHTOA right here again. And I'm going to look at what I have. From this theta angle perspective, this is the adjacent, because it touches it, and this is always the hypotenuse. So I have to use adjacent of a hypotenuse. I have no option. This is a cosine problem. The cosine of theta equals adjacent comes first, 13 over 24. My mode is in degrees. I still have the float on 1. I'm going to put this in my calculator because I want to find an angle, so I have to use inverse trig. So I have second cosine of 13 divided by 24, and that gives me 57.2. So theta is 57.2 degrees, and that's all they asked for, so we're done. Okay, now we're going to enter the world of oblique triangles. So things that we need for this page is going to be sine of A over A, little a, equals sine of angle B over B, equals sine of angle C over C. And if we are asked to do area, we have to do 1/2 AB sine C. Okay? All right. Here is our picture. Use the image on the right to identify how far points A and B are from the boat. So they want to find little a and little b. Your first job is to find this missing angle by subtracting from 180. So 180 minus 42.3 minus 68.9. That's going to give me an angle right here of 68.8. Okay, so this angle is angle C. This side is little c. So look at this next angle for angle B. Do you see how close those angles are? That tells me that little side B has to be a little bit bigger than side C. And that little side A is going to be the smallest side because of the fact that big angles beget bigger sides. Okay, so now we have a partnership. That partnership is between the angle of 68.8 and the side of 120. I'm going to find, I think I found side A first. So that's going to be the angle across from side A, which is 42.3. Make sure that you understand that this angle and that side go together. Do your cross products. A times the sine of 68.8 equals 120 times the sine of 42.3. Divide to isolate your A. When you divide by the sine of 66.8, you are getting A by itself. So this is sine of 68.8. So A, that side is going to be 86.6 after I put this in my calculator, and the units are going to be miles. Okay, so that's little side A is 86.6 miles. Okay, so now we need to do the other side, that's side B. So I'll change color, and I'll say over here, perhaps, the sine of 68.8, that's still my partner, with the 120 equals the sine of, carefully, 68.9 goes with little side B. Okay, because this angle is opposite that side. Okay, so B times the sine of 68.8 equals 120 times the sine of 68.9. So write this all out if you have any danger of messing up. Okay, don't put the stuff in your head and then type it in. Write it out so you see what you're doing. Okay, that will give me little side B, and I got 120.1, which is very close to 120, which is what we just talked about. The units are miles, so I'm going to say miles. Okay, find the area of the triangle. So you only have the formula that includes sine because it's not a right triangle, so I cannot use the other formula. So remember, don't get hung up on the AB sine C. Look for a sandwich. Okay, what did I do? I did, so I'll tell you where I looked. Let me just highlight them. My highlighter. Okay, I used these. I went that side, that angle, that side. That's my sandwich. Okay, so to do my formula, I'm going to have 1/2, which is just 0.5. The top side, the bottom side, I'll put them in parentheses so that you can see it, and the sine of the included, the sandwiched angle. Okay, I put that in my calculator, and I get a very big number, which makes sense because these are all miles. That is miles squared. Okay, so no matter which sandwich you picked, you should have roughly that amount. All right, let's go to the last problem. Okay, here you're going to do a sketch. So I'm going to draw my triangle. So since I know it's not right, draw it like this, okay? So I'm going to make this, I made this my A, this my B, this my C location. Then I'm going to put in what they gave me. So this is 46.7. Angle B is 32.7. And side C is 14.5. They say round all angle values and side lengths to 1 decimal. So my mode is on degrees and my float is on 1. Okay, so you need little side A, you need little side B, and you need this triangle, this angle C. You can do nothing until you get the angle C. So to get angle C, you're going to take 180 minus 46.7 minus 32.7, and you will get angle C is 100.6. So now I know that this 14.5 has to be the biggest side because it's across from the biggest angle. So the other two sides have got to be lesser numbers, okay, smaller numbers, smaller values. So let's set up our partnership. The partnership exists between the sine of 100.6 and the side length of 14.5. Oh, sorry, 14.5. Okay, so I'm going to find angle A first, or side A first. So take my angle A, which is 46.7, and put it over side A. Do your cross products. I'm going to write it all out for you. That's going to equal 14.5 times the sine of 46.7. Be in the habit of closing your parentheses on your angles when you put it in your calculator. Okay, I want to isolate my A, divide by the sine of 100.6. Okay, that goes in your calculator, and you should be getting side A is 10.7. Okay, that was less than 14.5, so that makes sense. Side B should be even smaller. Okay, here's your setup for side B. You're going to take, and now at this point, if this wasn't this quiz, I would have, oh, never mind. This is a situation where they gave you two angles, so you never have an ambiguous situation. It's when they only give you one angle that you could be ambiguous, okay? So forget I even said anything. Okay, so then this is going to be sine. Still keep your same partners. And now let's find the other side, which I said is going to be the smallest side because this is the smallest angle. And if it's not, we know we have a problem. Do your cross products. B times the sine of 100.6 equal, and again, you know, if you put this in your calculator, close those parentheses, equals 14.5 times the sine of 32.7. Isolate your B by dividing by the sine of 100.6. Okay, and you should get a B that's equal to 8.0. You want to have the 0.0 because I said to round to 1 decimal point. Okay, and that side is the smallest, so I know that I'm good to go. So what I solved for was this angle by doing subtraction, this side by doing law of sines, and then this side by doing law of sines. Okay, and that's the whole review. If you can do this, you can be highly successful. Thank you for listening.